So, Pulumi is an open source tool for managing cloud infrastructure as code. It supports multi-region, multi-account, and even multi-cloud deployments. Unlike AWS CDK, Pulumi does not compile the code to a CloudFormation template. Instead, it uses Terraform and the cloud provider's native SDK to provision and manage cloud resources. It uses the desired state model for deciding what changes need to be made by comparing the current and desired states. To start using Pulumi, you will need their CLI tool, which has the Pulumi engine embedded in it. You can install it using Homebrew by running brew install Pulumi, and then run Pulumi version for good measure to check that everything's working. Moving on to Pulumi Cloud, which is a vital component of using Pulumi, this is their SaaS offering, which acts as the backend for the Pulumi CLI. It stores the state of the infrastructure and provides a way to share the state with other team members. Pulumi Cloud is free to use. You just have to sign up or use one of the identity providers. You can also create your own custom backend or even self-host Pulumi Cloud, however, that is an enterprise-level solution. Pulumi has managed to amass nearly 20,000 stars on GitHub, which suggests that it is quite popular and an appreciated tool among software developers. It also cannot go without mention that Pulumi has their own AI assistant. This is a great tool and source of information about Pulumi. They have a very well-trained model that can generate a lot of useful code, albeit with some limitations and can be frustratingly slow. Still faster than trying to Google the answer yourself though. Nonetheless, it is an invaluable resource for learning Pulumi and getting started with whatever resources you need to create. To create a new project, you can use the Pulumi CLI and run the Pulumi new command. Should you not enter a template name, the CLI will prompt you to either select a template or write an AI prompt that will generate a starter project for you. You can select the language you want to use, the cloud provider, and the project name. At the time of writing, Pulumi supports TypeScript, Python, Java, .NET, Golang, and YAML. The featured providers are AWS, Azure, GCP, and Kubernetes, but there are over 150 packages available for different cloud providers and services. Some of the more popular ones could be Cloudflare, Docker, Auth0, Datadog, Grafana, but there are many more. The beauty of Pulumi is that you can relatively easily create your own packages using existing providers or even write your own completely from scratch. Let's see what a typical Pulumi project looks like. I'll be using TypeScript for this example, but the structure is similar for other languages. The project configuration is stored in the Pulumi YAML file. This file contains the project name, description, runtime, and language information. You can also use it to define a strongly typed configuration schema for your project or change the project structure to your liking. Pulumi programs are split into stacks, which is simply a logical separation of concerns. Each stack is a complete application, not to confuse it with stacks in CloudFormation that are an encapsulation of certain resources. When creating a project, you can either name your own stack, or Pulumi will use dev as the default stack name and create a Pulumi dev YAML file in the project root. This file contains the stack configuration and can be used to override the project configuration. Config in Pulumi projects can be as simple as key value pairs and as complicated as nested objects and arrays. You can also use it to store encrypted secrets, either with the Pulumi managed encryption key, a passphrase, or a secrets manager of your choice. Currently, you can choose between AWS, Azure, GCP, and HashiCorp. When first creating a project, Pulumi will create an index.ts file in the root of the project. This file is the entry point of the program and contains the code that will create the resources. Pulumi program structure is synchronous, even though provisioning resources is an asynchronous operation. Resources are often provisioned in parallel whenever possible. But when using resource values in other resources, Pulumi will automatically wait for the resource to be created before proceeding. They call it lifting the value, and it is based on their output generic type. You'll see it absolutely everywhere. When lifting the value is not possible, you can use apply on any of the available properties of a resource. For example, we can select any property on the bucket and use the apply method on it, and then use that property in the callback function. This is property specific though. Should you need to use multiple values at once, you can use Pulumi all with an array and then chain the apply method. When creating a string value, you can actually use Pulumi interpolate tag function instead of Pulumi all. So I can migrate this string here to Pulumi interpolate. Region is a promise, but that's not a problem. I can just use .then on it and return the value I want. Besides the actual cloud resource configuration, we can also configure how Pulumi will provision the resource by passing a third argument. Here you can see that in the bucket policy, I have configured a depends on property, which defines an explicit dependency for the policy to be public access resource, which basically configures the bucket to be publicly accessible. This is important because we cannot assign the policy that will make an object public without actually having the public access configured on the bucket. So there was a race condition here. If the public access was configured by the time when the bucket policy was being created, it was all good. But sometimes it wasn't, and there would be errors. So to remedy that, I had to add this explicit dependency. There's obviously more properties than that. We can see parent for binding resources together and creating a hierarchy. This is actually cooler than it sounds because any child resource will depend on the parent resource being created first, and often the child's lifecycle is tied to the parent's lifecycle. We can also protect resources from accidental deletion, probably good for databases or user pools. Key takeaway is that these are Pulumi specific configuration options and have no bearing on the resource itself. One more very important option here is provider. This one property opens up a world of possibilities as we can substitute the default provider for our own and deploy a resource to a different region or even a different account, and it is very simple to do. I'm using AWS, so I'll use a provider class from the AWS package and create a new instance. As you can see, there's a whole bunch of options. I can specify an access key and secret for a different account, a region, even the role it should assume. Once the provider is configured, all I need to do is pass it into the resource options object and Pulumi will handle the rest. The provider is a resource itself, so once I preview the stack, it will show up with the rest of them. So now I can also specify it as the parent and it will be reflected in the diagram. Anyway, as mentioned previously, Pulumi uses stacks to handle different development stages, like production, development, QA, or maybe creating ephemeral environments for feature branches. You can manage stacks with the Pulumi CLI using the Pulumi stack command. If used by itself, it will print your current stack's information. Then I can create a new stack with Pulumi stack init and move back to dev with Pulumi stack switch. I can list all available stacks with Pulumi stack ls and remove a stack with Pulumi stack rm. Pretty intuitive if you ever navigated using a terminal. If you need to refresh your memory, you can use Pulumi stack help for that. Most, if not all, programs will output some data, whether it's an IP address, a bucket URL, or a database password. You can define outputs in the entry file by simply exporting them. Every time you run Pulumi up or Pulumi preview, the outputs will be printed to the console. They are also visible in the Pulumi Cloud dashboard, or you can use Pulumi stack or Pulumi stack output command to view them. Outputs are not only useful for easy access to the resource data, but can also be used to compose multiple Pulumi programs together. You can use the stack reference class to reference another stack's output. The pattern is account name /project name /stack name. This is very useful for separating concerns into multiple projects rather than having an entire infrastructure from VPC to single Lambda functions in the same project. To provision the resources, use the Pulumi op command, which will calculate the required changes and prompt you to confirm. Once it's done, you can go to the Pulumi Cloud dashboard with the generated link and see your stack there. Whether you want to check the config or see the provisioned resources, it's all in one place, and we can use the links to view it in the AWS console too. That's a very nice touch from the Pulumi team. Now I'm gonna use Pulumi down to tear it down. Okay, I forgot that I have a protected resource, that's why it doesn't let me do it. So if you're in the same spot, you have to first update the resource to be no longer protected and then repeat the Pulumi down. And I'm just gonna move on because I cannot finish this video without comparing Pulumi with AWS CDK. They are similar in that they both allow you to define cloud infrastructure using programming languages. However, there are many key differences between the two. Pulumi supports multiple cloud and service providers, while AWS CDK is specific to AWS. Pulumi uses cloud providers' SDK or Terraform to create and manage resources. CDK compiles the infrastructure code to CloudFormation templates and then sends it over to CloudFormation, which basically takes over from there and we have no idea what's going on. Pulumi provides a fairly low-level API for provisioning resources, which makes it more verbose as you have to define everything yourself. Whereas AWS CDK provides many batteries-included constructs that abstract away a lot of the boilerplate code and lowers the entry threshold. CDK obviously benefits from being the official AWS tool, which cannot be ignored. It would seem that the official tool would have a larger community, but I'm not so sure about it. Pulumi has almost double the stars on GitHub, which of course doesn't mean that the community is larger, but at least it's more appreciative of the tool, and that could mean more engagement from the community. So even though the community size is undecided, it would seem that developer satisfaction is definitely on Pulumi's side. Still, CDK probably has more resources available online, and it has a tight integration with the AWS ecosystem, like the CDK Migrate service for exporting the existing infrastructure to CDK code. But the CDK also requires you to have a significant understanding of CloudFormation because it inherits its strengths but also its weaknesses, which often lead to hard-to-debug errors that cannot be solved by simply analyzing the CDK code itself. So to sum up, Pulumi offers a flexible and powerful approach to managing cloud infrastructure as code. Personally, I find Pulumi to be a great tool and have not used CDK since. I find it to be more flexible and eventually easier to use, especially when creating custom resources. Even though it is more verbose and a bit harder to use at first, I appreciate the control it gives me and it improves my AWS knowledge as I have to provision everything myself and cannot rely on the magic constructs to do all the heavy lifting for me. That's it for this video. Thanks for watching.